Hello everyone and welcome to section 3.4, which concerns contingency tables. Yay, exciting. Okay, so first of all, let's get into it. Let's go ahead and define what a contingency table is. Okay, so a contingency table is just a way of portraying data that makes it easier to figure out the probability of whatever it is that you're trying to find out. Okay, so it's also super helpful with finding conditional probabilities. Okay, so you have different values so the cool thing about a contingency table is that you can look at several variables at once. Okay, and basically you can ask a set of people different questions and you can gather information, and it's a really nice way to organize it. So let's say for example, there was a study on speeding violations and the use of cell phones. Okay, so they asked a total of 755 people. So notice here that this is the total. Okay, so out of those 75 people, they asked the following questions. They asked, did you get a ticket or not in the last year? Did you have any speeding violations? Yes or no? Okay, and they also asked, well, did you use a cell phone while you were driving or not? Okay, so let's say here, so out of the 755, 305 of them use a cell phone while driving, and 450 do not use a cell phone while driving. Okay, and then additionally, of that 755, 70 of them got a speeding violation in the last year, and 685 did not. Okay, so these row totals, this is called the row total because this is a row, right? Horizontal is a row, and this is the total of that row, and this one also. Notice that if I add these together, I get the total amount of people, which makes sense, of course, because you're asking them, hey, did you do this or not? And then that's their response. Okay, so the cool thing too, so these add up to each other, and these two add up to 755. And the other interesting thing is that the rows and the columns add up to each other. So 25 plus 280 will give you a total of 305. So out of all the cell phone users, 25 of them got a speeding ticket and 280 did not. You see what I'm saying here? Out of the 450 non-cell phone users, 45 got a speeding ticket and 405 did not. Okay? Another way to think of it is looking this way. So out of the total number of people that got a speeding violation last year, 25 of them used a cell phone and 45 of them did not. Out of the total number of the sample that did not get a speeding violation, 280 of them used a cell phone and 405 did not use their cell phone while driving. Okay, so let's do some questions. So find the probability that the driver is a cell phone user. So what do you think that would be? Remember that we're counting the event over the total possible outcomes. So let me give you a few seconds to figure that out. Okay, so let's see. Did you get so to find the probability that the driver is a cell phone user, you take the number of cell phone users over the total number in the study. So here's the number of cell phone users, 305, over the total, which is 755. Let's do another one. Let's see if you can find the probability that the driver had no violations in the last year. So let me give you a couple seconds, or you can pause this video to see if you can figure it out for yourself. All right. So to find the probability of drivers that had no speeding violations this last year out of the sample, you take the number of people that had no violations over the total number in the study. So here's the number of people that did not have any speeding violations, 685, over the total, which is 755. Okay, so let's try another one. Let's see if you can find the probability that the driver had no violation in the last year and was a cell phone user. So let me give you a second. So let's see if, so hint is that it's an and, okay? So let's think about that. So driver had no violation and was a cell phone user. So see, this is the intersection of this column and this row. So 280 people in the study had no speeding violation and also used their cell phones. So 280 out of the 755. Okay, so what about the or? Okay, so find that the driver is a cell phone user, or the fact that the driver had no violation in the last year. So this is the row that represents cell phone usage, and this is the row that represents non-tickets. So let's look at that. So do you remember the addition rule? Okay, let's find the probability that the driver is a cell phone user given that the driver had a violation in the last year. So let's think about this before we answer it. How would we work that out? What exactly would you do? What do you remember about conditional probability? Because we know this is a conditional, right? We know that because of this given right here. So remember, the given reduces what? It reduces the sample space. Okay, so if we know that the driver had a violation, we're talking about this set of people, the 70 people, okay? And out of that many, 25 of them had a cell phone. So that's 25 over 70. Okay, so remember, conditional reduces your sample space. Okay, let's try this one. Find the probability that the driver had no violation given that the driver was not a cell phone user. So if the driver, this is the conditional, right? It comes after the word given. So that's what reduces our sample space, that phrase after the given. So, or in other words, you can think of that as your condition. So how many people were not cell phone users in the study, cell phone users while driving? 450, right? Okay, and then what did they ask? Out of that, how many drivers had no violation? So 405. So 405 out of 450, because the sample space is reduced to the drivers that were not cell phone users. And that's pretty much it for contingency tables. Pretty short and sweet. And this is your homework, 54 through 57 all. And again, great job keeping up with everything. Keep at it. Don't give up. Okay, we're starting super strong, so I want us to continue all the way through. All right, so I will see you in the next video.